In one of our earlier videos, we had a look at inverse functions. And we saw that there is a line on the Cartesian plane, the line y equals x. And if we reflect a point, let's say we've got a point here, minus 1 and 3. If we reflect it over this line y equals x, we'll end up with 3 and minus 1. And that is also how we determine the inverse of a function, is we reflect about that line y equals x. And so we even saw that our coordinates shift and xy becomes yx. Now let's take a look at what happens when we reflect an exponential function in order to find its inverse. Okay, so we're going to take a couple of points here. It's always a good idea to take the intercept. So let's take that point there. X is 0 and y is equal to 1. So when we reflect it, we're going to swap our x and our y, and we're going to plot the point 1 and 0. Then let's take another point. Here's a point 2 on the x-axis and 4 on the y-axis. And when we reflect that and we get the inverse, it'll be 4 on the x-axis and 2 on the y-axis. Okay, so we've got 2 points so far. Let's take one more point down here so that we can figure out what's going to happen in this region. So if we have a look closely at the graph, we could probably take the point here, which looks to me like minus 1.5 as points there. So then we're going to reflect that, and we're going to plot a half on our x-axis and minus 1 as the y coordinate there. So a half and minus 1. All right, let's draw this graph. There we go. That would be our inverse graph that we've drawn. And if we drew it very accurately, what we would notice is we could fold this set of axes on that yellow line y equals x, and the two halves would touch. But I'm interested to know, because this is a new type of function that we've just drawn. So let's have a look at the theory behind it. Now remember, we learned that if you want to find the inverse of something, you need to switch around the x and the y coordinates. So the inverse would then be x is equal to 2 to the power of y. But we don't usually write our equations like that. For something to be in the standard form, y needs to be the subject. And so we need to now go to some of our newer or more recent knowledge, and that was that we can use logs to make y the subject. So y is equal to log, and then remember what we said, the number here that was the base becomes the base of our log. So it's going to be log base 2 of x. And so what we've just done, grade 12s, is we have drawn a log graph, log base 2 of x. And so a log graph is the inverse of an exponential graph. Let's put our new knowledge to the test. So determine f to the minus 1, in other words, the inverse of the following. And we have got here for a f of x equals 5 to the x. So what we want to do is we want to first of all understand that f of x is representing y. And in order to get the inverse, I need to switch around the x and the y. So x is going to equal 5 to the y. And then I need y to become the subject, and so I'm going to use logs. Y is equal to, now the base here is going to be the base of my log, so log base 5 of x. So what is the inverse of f of x equals 5 to the x? It is f to the minus 1 of x is equal to log base 5 of x. Okay, not to be confused when we get to a fraction here. It's very important, these brackets, because they show that that whole fraction is being raised to the power. But we're going to follow a very similar principle. So this is y, and we want to switch out y and x to create the inverse. So x is equal to a half to the power of y. And now we want y to be the subject. So we're going to say y is equal to log base a half of x. And there you have it. So our inverse, f to the minus 1 of x, is equal to log, you can write base a half or 0,5 of x. Now let's look at some examples of what we might see in a test or exam. Okay, so we are told here that the graph of f, which is a to the x, passes through the point -1 and a half. And then we're asked to determine the value of a. Alright, so that is actually quite a straightforward question. We're dealing with an exponential graph, and in fact, this is probably an exponential graph they could have already given us in grade 10. So we're going to start off, and we're just going to ease into this, and we're going to say, okay, well, question 1, determine the value of a. I can substitute in this point that they've given me because I've got an x and a y coordinate, and my equation contains an x and a y. So what I'm going to do is instead of y, I can write a half, and instead of x, I can write -1. So I've got a to the -1 is equal to a half. Okay, this is currently 2 to the power of 1. I want to try and get same bases here. So I'm going to make that 2 to the -1 is equal to a to the -1. And then what I notice is that instead of getting the same bases, which is generally my goal with exponential equations, what I've actually got is the same exponent. And that has pretty much achieved a good result for me. So I can then conclude that a is equal to 2, because if they both raised to the power of -1, then they are in fact going to be the same bases there. Okay, then question 2 says determine the inverse of f. So now I know what the equation of f is. F of x is equal to 2 to the power of x. Okay, so I can easily determine the inverse now by saying, well, that's y. Y is equal to 2 to the power of x. So let's switch that out, and we'll end up with x is equal to 2 to the power of y. And then I need y to become the subject, so y is equal to log base 2 of x. Okay, so as long as you can remember that the base of your exponent becomes the base of your log, you will be okay. Alright, and then just to give them the answer fully, f of -1 to the x is equal to log base 2 of x. Okay, and then what comes often at grade 12 level is they want us to sketch the graph of f, so that was f there, 2 to the x, and its inverse on the same set of axes. Okay, so here's a neat system of axes, and we are going to be able to plot the graph and its inverse because we've even got this line here, y equals x, as a guide for us. Okay, so what I want is I want to try and find an x and a y intercept. Okay, what I can straight away see is that seeing as though this equation here, y is equal to 2 to the x, is plus 0, I do have an asymptote there at 0, if you remember correctly back to your exponential functions. So that is already something in place there. That's the line y equals 0. Okay, that means that I'm not going to be able to get an x-intercept because my whole axis is in fact an asymptote. Okay, but I can definitely get a y-intercept. Okay, how do we get a y-intercept? We let x equal 0. So we're going to take the equation, we're busy working with f there, and we're going to say y is equal to 2 to the power of 0, and anything to the power of 0 is equal to 1. So what does that mean? That means that x equals 0 and y equals 1. So I can now plot a point when x equals 0, y will equal 1. That is going to be one of my coordinates, 0 and 1. Okay, and then I can choose any other coordinates. I already have a basic idea because I can see that this is a whole number bigger than 1. So it's going to be an increasing function, but it is always better to have at least 2 points when you plot. So let's choose another point here. Let's go with the point 2, and we're going to substitute in, and we're going to see what we get. So what is f of 2? Okay, well, the equation is 2 to the power of x. So that's going to give me a 4. So now when x is equal to 2, y is equal to 4. Okay, so there I have 2 points on my exponential function, and that is the graph of f. Okay, and now I need to sketch the inverse, and you might be tempted to go and start working things out all over again, but let me show you how these are going to play together. Okay, so we actually can already straight away say, well, the y-axis is going to be my asymptote now. because remember, when we work with inverses, x and y swaps out. So in this case, the x-axis was my inverse of f, was my asymptote of f. And now in the next one, this line here, the y-axis, is going to be the asymptote of the inverse. And then I'm simply going to take these 2 points and I'm going to switch them out. So I'm going to say instead of 0 and 1, I can plot a point at 1 and 0. And instead of 2 and 4, I can plot a point at 4 and 2. And there, with very minimal effort, I can actually draw that graph, log base 2 of x, okay, also known as f to the minus 1. So there you have it. As long as you understand that an exponential function has an inverse that is a log graph, and that as long as you've got some points where you can switch your x and your y coordinates out, you will be able to draw both the function and its inverse. Okay, what about something like this, where we are starting off with the log graph, passing through 8 and 1.5 as its points, and then they want us to determine the value of a. Okay, well, let's see if we can do the same thing, where we substituted in an x coordinate and a y coordinate. What are we going to end up with if we do that? So question 1, instead of y, we're going to write 1.5. I'm going to write that as 3 over 2 is equal to log base a of 8. Okay, now this for us to solve is a bit tricky because a is the unknown, the thing we want. But what I do know is that I can make a the base of the exponent, okay, and that way, so I can rewrite this back in exponential form. Okay, so a to the power of 3 over 2 is equal to 8. Okay, let's check that. We would have said a would be our base, then the number on the other side becomes the number of the log, and this, which was the exponent, or now becomes the exponent because we're working backwards, is the thing that would have been the subject of the formula. Okay, so a to the 3 over 2 is equal to 8. Okay, what's actually happening here? Let's go back to our laws of surds that we learned at grade 11 level. This is the square root of a cubed, if you think about it, because it is the inside power divided by the outside root. Okay, so we're going to do a couple of things. The first thing we're going to do is we're going to square this side, and let's get that 8 over there. We're going to square that side so that we can get rid of that root. So then we'll have a to the power of 3 is equal to 8 times 8, which is 64. And now, strangely enough, we're going to cube root over here. And what I do to the one side, I do to the other side. So what times itself 3 times gives me 64. And that answer there is 4. So a is equal to 4. Okay, now if you're comfortable, you are welcome to do that in fewer steps, but I always like to just see it unfold very systematically. And now they want the inverse of f. Okay, so we're dealing with a log function, and we want an exponential function. Okay, so this here brought us to the conclusion that f of x is equal to log base 4 of x. Okay, and now to get our inverse, we want to switch those around, and we want to say, okay, well, x is equal to log 4 of y, and now I want to end up with y on its own, so y is equal to 4 to the power of x. Okay, which is the same as f of minus 1, that's what we were working out, is equal to 4 to the power of x. Okay, and then in a very similar way, they want us to sketch the graph of f and its inverse on the same set of axes. Okay, and we've got options here, but I strongly advise that we start by drawing this graph here. Okay, you're welcome to draw the log graph if you're more comfortable doing that, but seeing as though we've drawn exponential functions for so long, it might actually make sense to start with the inverse and then reflect to get the original function in this question. Okay, so 4 to the power of x, we want to figure out where's our asymptote, and this is very similar to the one we just did. The asymptote is going to be here on the axis. Okay, Then we want to figure out a y-intercept. Once again, there's no x-intercept. How do we get a y-intercept? We let x equal to 0. And we do that in this equation here. So we're going to say y is equal to 4 to the power of 0. And that is just equal to 1. So again, we've got a very similar y-intercept. Let's see what happens next. Okay, we need another point here before we feel comfortable plotting. So let's work out f minus 1 of 1. Okay, so in our equation, which is 4 to the power of x, we're going to substitute a 1, and what we end up with is 1 and 4. So there we go, 1 and 4, and this point here was 0 and 1. And then we're ready to draw and to label. That was our inverse graph, which we decided to start off with. Okay, and then we can follow similar steps, and we can say, well, our next graph is going to have an asymptote there, and we can once again switch around our x and our y values, and we can very easily plot this graph here at 4 and 1. There we go. There is the log graph. Okay, so f of x.